Hi grade 10 students, this video will discuss the lessons for week number 6, synthetic division, remainder theorem, and factor theorem. So the objectives are: illustrate the process of synthetic division, divide the polynomial by a binomial of the form x minus c using synthetic division. Synthetic division is an abbreviated way of dividing a polynomial by a binomial of the form x minus c. We can simplify the division by detaching the coefficients. So let's have an example. Evaluate x cubed minus 8x plus 3 divided by x plus 3 using synthetic division. So x cubed minus 8x plus 3 divided by x plus 3 using synthetic division. So the first step is to arrange the terms in the dividend in descending order according to its degree or exponent, or descending power of x. So obviously in this example, the terms are already arranged in descending power of x. The power of x here is 3, while the power of x here is 1, and then this one is the constant term. So it's already arranged in descending order, the power of x. So we will proceed with the second step. The second step is to do the setup for the synthetic division. So we are going to detach or write the numerical coefficient of each term. So from this dividend, what we can see are 1, negative 8, and positive 3. But we need to write 0 as a placeholder for each missing term. What do you mean by missing term? We started with a term with a power of 3, x to the power of 3, and there is no x to the power of 2 or x squared in this polynomial. So that one is the missing term. So for that, we're going to write 0 as a placeholder. So let's start with x cubed. Its numerical coefficient is 1. And then since there is no x squared involved here, then we are going to write 0 as a placeholder. And then for x raised to 1, its numerical coefficient is negative 8. And lastly, the constant term is positive 3. There. Next is to write here the value of c. So to get the value of c, we are going to equate the divisor, which is x plus 3, to 0. So equate it to 0 and get the value of x. So to get the value of x, we're going to transpose positive 3, so it will become negative 3. That's the value of x, and that will be our divisor for synthetic division. You write it here. Alright, so we are now ready to do the synthetic division. So we have 3 steps. First, bring down the first numerical coefficient, then proceed to multiplication, and then proceed to addition. Then after addition, you'll go back to multiplication, and then after multiplying again, you'll go back to addition. Okay? So, alternately, you'll do multiplication and addition until you reach the last column. So we start from the left column or left side to the right side or to the last column. Okay? So let me show you. So again, the first step is to bring down the first numerical coefficient, which is 1. So bring it down here, write it here. Then next step is to multiply. We are going to multiply the number here at the bottom to the divisor. So 1 times negative 3, the answer is negative 3. We write the answer here below 0. Okay. So we're done multiplying. Next to it is addition. So we are going to add these numbers vertically. So 0 plus negative 3 is equal to negative 3. You write the answer here. And then after addition, we go back to multiplication. So this number, we are going to multiply this again to the negative 3. So negative 3 times negative 3 is positive 9. So we write the answer here below negative 8. Then addition again. Negative 8 plus 9 is equal to positive 1. Then again multiplication. 1 times negative 3 is negative 3. We write the answer here. And then lastly, add these numbers. 3 plus negative 3 is equal to 0. Alright, so that's it. That's how synthetic division is done. Now, for the answer, the last number here, or the last digit here, is for the remainder. It is the remainder. Okay, so in this example, the remainder is 0. Next, for the quotient, remember, quotient is the answer in division, and we are dividing polynomials by synthetic division. So for the quotient, this will be the numerical coefficients. Okay, so again, the last digit is the remainder. Next to it, this will be the new constant term. So from the dividend, the constant term is 3, but for the quotient, the constant term is 1 or positive 1. Then, after the constant term, the next term to the left is negative 3 with an x. So we are going to bring back x here. And then, next to negative 3, x is, the term to its left is 1 with an x squared. Okay, therefore, the quotient is 1 x squared, then minus 3 x, and then the constant term is positive 1, so plus 1. Right? So, can we delete or can we erase 1 here? Yes, because if there is no number seen here, it's automatically 1. So the quotient is x squared minus 3x plus 1. Where does this thing come from? It comes from these digits. 1, negative 3, 1. 1, negative 3, 1. Remainder, constant term. Then next to it is the term with an x and the term with an x squared. Alright? Now, if you are asked to give the quotient is x squared minus 3x plus 1. If you are asked to give the remainder is 0. But if you are asked to write your answer in the form q of x plus r of x over d of x, meaning your answer should be written in this form, quotient plus remainder over the divisor. Then we need to write it in that form. So, with this instruction, your answer should look like this. The quotient is x squared minus 3x plus 1. So, x squared minus 3x plus 1 plus r of x is the remainder. So, our remainder is 0 over d of x is the divisor. Our divisor is x plus 3. So, x plus 3. There. But, since we know that 0 over x plus 3 is also equal to 0, therefore, your final answer will still be x squared minus 3x plus 1. Okay? So, in this example, there's no use of writing the remainder over the denominator since our remainder is 0. Okay? So, but I just demonstrated how you're going to write the answer in the form q of x plus r of x over d of x. Alright, so that is the answer. Next example, divide the polynomial 3x squared minus 5x plus 8 by a binomial x plus 2. So 3x squared minus 5x plus 8 divided by x plus 2. Again, the first step is to arrange the terms in the dividend in descending power of x. So let's look. So the power of x here is 2. The power of x here is 1. And this is the constant term. So it means it's already arranged. So let's proceed with the second step. So let's have the setup for the synthetic division by detaching or writing the numerical coefficient. So what we see here, the numerical coefficients here are 3, negative 5, and positive 8. Is there a missing term? No, there is no missing term. We started with x squared, followed by x raised to 1, and then the constant term. So there will be no 0. We don't need to write 0 or the placeholder. So we write the numerical coefficients 3, negative 5, and positive 8. Next, our divisor is negative 2. Okay, so where does it come from? It comes from the divisor x plus 2 equating to 0 and getting the value of x. And that will be negative 2. Right? So again, for doing the synthetic division, first, bring down the first digit. Next, multiply. 3 times negative 2 is equal to negative 6. And then add negative 5 plus negative 6 is equal to negative 11. Then multiply again. Negative 11 times negative 2 is positive 22. And lastly, add the numbers 8 plus 22, that is equal to 30. So if the question is what is the remainder, your answer is 30. The remainder is 30. Next, if the question is what is the quotient, the quotient is, remember this one is the constant term, and then next to it is the term with an x. So the quotient will be 3x minus 11. That is the quotient. And then again, for the instruction, write your answer. After dividing these polynomials, write your answer in the form q of x plus r of x over d of x, which means quotient plus remainder over divisor. Then your answer should look like this. The quotient is 3x minus 11 plus the remainder is 30, so we write 30 here, over the divisor, which is x plus 2. X plus 2. So your answer should look like this. Next one. 2x raised to 4 plus 7x squared minus 6 divided by x plus 3. Okay, so are the terms here already arranged in descending power of x? Yes. So we are going to write the numerical coefficients now. Now the numerical coefficients that we can see are 2, 7, and negative 6. But there are missing terms. What are those? The term with an x cubed and the term with an x only. Okay, so there are two missing terms, so we're going to write 0 for as a placeholder for those terms. So for x raised to 4, the numerical coefficient is 2. For x cubed, there is no x cubed here, so write 0. And then for x squared, the numerical coefficient is positive 7. And for x, so there's no term here with an x only, so another 0 for that. And lastly, for the constant term, negative 6. And then our divisor will be negative 3. Alright, so bring down the first digit, multiply. 2 times negative 3 is negative 6. Write your answer here. And then add the numbers. 0 plus negative 6 is equal to negative 6. Then multiply again. Negative 6 times negative 3. Negative times negative is positive 18. Alright, and then add 7 plus 18 is equal to 25. Then 25 times negative 3 is equal to negative 75. And then add 0 plus negative 75 is equal to negative 75. And then next, negative 75 times negative 3 is equal to positive 225. There. And then, adding negative 6 and positive 225 is equal to positive 219. There. So, again, what's the remainder? The remainder is positive 219. And how about the quotient? So this will be the constant term, and then the term with an x, the term with an x squared, and the term with an x cubed. So the quotient will be 2x cubed minus 2x cubed minus 6, negative 6, so minus 6, x squared, and then this is positive, so we write plus 25x minus 75. That is the quotient. Okay. Now for the instruction, write your answer in the form q of x plus r of x over d of x, or quotient plus remainder over divisor. Your answer should look like this. There. So, the quotient 2x cubed minus 6x squared plus 25x minus 75 plus the remainder 219 over the divisor x plus 3. So, this will be your final answer for that instruction. Next example, negative 4x cubed plus 8x squared plus 12x plus 16 divided by x plus 2. Okay, so are the terms already arranged? Yes. The powers are 3, 2, 1, and then the constant term, obviously there is no missing term here, so there will be no 0 or placeholders. So, let's write the numerical coefficients, negative 4, positive 8, positive 12, and positive 16. There. And then our divisor will be negative 2. Okay. So, bring down negative 4. Negative 4 times negative 2 is positive 8. And then add 8 plus 8 is 16. Next, 16 times negative 2 is negative 32. And then adding these numbers, positive 12 plus negative 32 is equal to negative 20. And then negative 20 times negative 2 is equal to positive 40. And then adding these numbers will give us positive 56. So remainder is 56. And then the quotient is constant term with an x, and term with an x squared. So it's negative 4x squared plus 16x minus 20. That is the quotient. Alright, so let's proceed with the remainder theorem. Now, the remainder theorem states that if a polynomial f of x is divided by a linear divisor x minus a or x minus c, the remainder is f of a or f of c. When f of x is divided by f minus a, we get f of x equal to x minus a times q of x plus its remainder. That is, f of x is equal to x minus a times the quotient q of x plus the remainder f of a. So, the remainder theorem is another way to find the remainder when you are dividing polynomials. So, if your main objective or your main if your main objective is just to get the remainder, you don't need the quotient, you may apply this remainder theorem. So again, given polynomials, given a polynomial f of x divided by a binomial which is the divisor, and you are just concerned of the remainder, then you may use the remainder. Find the remainder when f of x is equal to 4x cubed plus 3x squared minus 5x divided plus 1 divided by x minus 2. Okay, so if our concern is just to know the remainder when these polynomials are divided, one way is by applying the remainder theorem. So how it is done is, let's first find the value of c, x minus c, or to get the value of c, we are going to equate this divisor x minus 2 to 0, and then get the value of x. So the value will be positive 2. Transposing negative 2 to the right side, we'll have positive 2, and that will be the value of our c. So, given f of x, which is 4x cubed plus 3x squared minus 5x plus 1, to know the remainder when these polynomials are divided, we will simply get the value of f of 2. Okay? So where does this 2 come from? That is the value of c in the divisor. So, we will just replace or substitute all x's here by positive 2. So, copy 4, replace x by 2, place x by 2, then copy the exponent, and then plus 3, again replace x by 2, copy the exponent, then copy negative 5, and then replace x by 2 again, then copy plus 1, there, and then evaluate. So we have 4 times 2 cubed means 2 times 2 times 2, which is equal to 8, plus, copy 3, and then 2 squared means 2 times 2, which is equal to 4, and then negative 5 times 2 is equal to negative 10, and then copy positive 1. Next, let's multiply these numbers. 4 times 8 is equal to 32, plus 3 times 4 is equal to 12, and then followed by minus 10 plus 1. And then lastly, 32 plus 12 is equal to 44, minus 10 is equal to 34, plus 1 is equal to 35. There. So f of 2 is 35. It means when you divide this polynomial to this binomial, whether it's a long division method or synthetic division, the remainder will be equal to 35. So again, if your concern is just to know the remainder, then this is one way to get the remainder, applying the remainder theorem. So you will simply substitute all x's by the value of c. Okay, so that's it. Now, next one is the factor theorem. The factor theorem states that a polynomial f of x has a factor x minus a if and only if f of a is equal to 0. It is a special case of the remainder theorem where the remainder is equal to 0. From the remainder theorem, we get f of x is equal to x minus a times q of x plus f of a. So the factor theorem is somewhat like almost the same as the process in remainder theorem. We use this factor theorem in order to know if the divisor given or if a certain binomial given is a factor of the polynomial. Okay? When we say factor, it means there will be no remainder, or the remainder is equal to 0. So, tell whether the second polynomial is a factor of the first. Given 2x cubed plus 5x squared minus 8x plus 16. So, this is the polynomial, and we are to find if the binomial x plus 4 is a factor of this polynomial or not. Okay? So, for this binomial to be a factor of this polynomial, when we divide this, the remainder should be equal to 0. That's how this binomial becomes a factor. If the remainder is 0 after dividing this, whether you use synthetic division or long division method. So, applying the remainder theorem to prove that this binomial is a factor or not, so we are going to find the f of negative 4. Okay, so it means when we divide this binomial by x plus 4, this will reveal the remainder. Okay, so this is just like the remainder theorem, finding out the remainder. So if the remainder is 0, then we can state that this is a factor of this polynomial. But in the case that the remainder, the result or the remainder is not 0, then we can conclude that x plus 4 is not a factor of this polynomial. So again, let's find the remainder first by replacing all x's by the value of c, which is negative 4. So copy 2, then replace x by negative 4, copy the exponent 3, then plus 5, another x, replace it by negative 4, copy the exponent 2, then minus 8, another x, replace it by negative 4, and then plus 16. There. So it's just it's just like the remainder theorem. We are finding out the remainder when these two will be divided. So 2 and then negative 4 cubed means negative 4 times negative 4 times negative 4. And that is negative 64. Yeah. Then, copy positive 5. The negative 4 squared means negative 4 times negative 4, which is equal to positive 16. And then let's multiply these numbers. Negative 8 times negative 4 is equal to positive 32. And then followed by plus 16. There. So next is to multiply these numbers. 2 times negative 64 is equal to negative 128 plus 5 times 16 is equal to 80, and then plus 32 plus 16. Alright. So next, negative 128 plus 80 is equal to negative 48 plus 32 is equal to negative, so negative 48 plus 32 is negative 16. Plus 16 is equal to 0. There. What does it mean? It means that when you divide 2x cubed plus 5x squared minus 8x plus 16 by x plus 4, the remainder will be 0. Whatever method you're going to use, whether it's long division method or synthetic division, when you divide them, the remainder is 0. So, since the remainder is 0, we can now conclude that x plus 4 is a factor of 2x cubed plus 5x squared minus 8x plus 16. So, it says that tell whether the second polynomial is a factor of the first. The answer is yes. Yes, the second polynomial is a factor of the first. Next one, find the value of k so that x plus 2 is a factor of x cubed plus 4x squared minus kx minus 30. Okay, so x cubed plus 4x squared minus kx minus 30. Now, for this polynomial, it is given that the binomial x plus 2 is a factor of this. Meaning, if x plus 2 is a factor of this polynomial, then there should be no remainder, or the remainder should be equal to 0. So from there, we can find the value of k. Alright, so means the value of c here is negative 2. So f of negative 2 is equal to x cubed plus 4x squared minus kx minus 30. Alright, remember that f of negative 2 gives us the remainder when this polynomial is divided by x plus 2. Alright, now since it says that this one is a factor of the first, then it means the remainder should be equal to 0. So, meaning, as we replace all x's by negative 2, so let's replace it. all x's by -2. There. So as we replace all x's by -2, the remainder should be equal to 0. Why? Because it says that x plus 2 is a factor of x cubed plus 4x squared minus kx minus 30. So if that is really a factor, then its remainder should be equal to 0. So as we replace all x's by -2, it should be equal to 0. And from here, we can find the value of k. So we'll have 0 equals -2 cubed means -2 times -2 times -2, which is equal to -8, plus 4. -2 squared means -2 times -2, which is equal to +4. And then negative k times -2, so negative times negative is positive, 2k minus 30. There. Next, -8 plus 4 times 4 is 16 plus 2k minus 30. Then, we can combine these terms. So, as we combine these terms, -8 plus 16, that is equal to +8. +8 minus 30 is equal to -22. And then plus 2k. There. Alright, so to get the value of k, we transpose -22 to the left side. So it will become +22 is equal to 2k. And then divide both sides by 2. There. So k, 22 divided by 2 is 11. There. So the value of k should be 11 to make x plus 2 be a factor of the polynomial x cubed plus 4x squared minus 11x minus 30. So that's it. Those are the lessons for week number 6. Thank you.